imagine today we're going to do what we did yesterday, except instead of multiplying and dividing, we're going to add and subtract. How do you add and subtract fractions? Now, common denominator. Now, of course, you could probably do this in your head, but I'm going to remind you of the thought process we're going to go through. Isn't 8 2 times 4? So I'm factoring the 8 so that I see what it's made up of. And I actually could factor it farther down, but that's far enough to see some things that we already have in common with the 1/2. Remember the very corny cool kid discussion? You'll remember that? I want the 1/2 to get to have everything the other two fractions have. What does it need? Good. So what do I need to multiply it by? What does this fraction have that this one doesn't have?
3.
So it feels like junior high, right?
Yeah.
Everything they want. All right, so 3/3. Is that enough to make it look like both of these? What does it still not have?
4.
A 4. Now I know some of you could have done this faster numbers-wise, but this will help us when we get to the ones with X's in it. What does the 1/3 need? A 2 and a 4. And what does the 8 need? Just a 3. So I get 12/24. Good. And some of you, like I said, because these are just numbers, knew the common denominator was 24 and could get there a little faster. 8/24. And 9/24. Add those all together and I get 29/24. Which one? Sorry. Oh, good call. Because the answer to that is because I wasn't paying attention. Thank you. I should not have added the 9. So it should be 11. That sound better to you all? Good call. I'm glad y'all are on top of things this morning. I'm obviously not. Okay, any questions about that? All right, so now we're going to work with things with letters in them. What do you notice about the first set of fractions there? They all have the same denominator, so what do I need to do? Just add across the top, right? So what do I get? I get 8x plus 7x minus 2 minus 7x. Good. Why is it 8x minus 2? Good. So if the denominators are the same, that makes for a very easy problem. You just add across the top, leave the bottom alone. Are these two denominators the same? Which one is lacking? The one on the right. Would you agree the one on the left has an x plus 9 and another x plus 9? So the one on the right needs an x plus 9 if it wants to be like the one on the left. Any questions about that? Is this easier than the first time we learned it? Maybe? Where did I get 72 from? 9 times 8, good. The denominator is common, so I just write it down. And then 72 plus 2 is 74. I could look to reduce this as well, but 72 and 8 They have some common factors, but not enough to get all the way down to an x plus 9, so it's not going to simplify. Oops, sorry. Didn't mean to go that far. Okay. Look at the next one, the bottom left. Are those denominators the same? Are they awfully close?
Yep.
So I don't really need to multiply each denominator by the other one. In fact, that would make the problem much more complicated than it needs to be. Would you agree with that? So, what do you suggest? Either take out a -1 or multiply one of the two fractions by -1 over -1. Either way works great. Remember, all we need is a -1 to change a 2 minus y into a y minus 2. So you can either factor one out, or if you like the common denominator thought process, you can multiply by -1 on top and bottom. So then I get -5 over y minus 2 minus 2 over y minus 2, which is -7 over y minus 2. I am going to put an or here. If you work this slightly differently, you could have gotten a +7 over 2 minus y. Why could you get a +7 over 2 minus y and those two things be the same? It's just it would be if I had multiplied the right one by -1 on top and bottom instead of the left one. So there's no magic reason I picked the left one except that we're used to seeing y's in front, but you could have picked either one. What is the only thing that I can do to get a common denominator? What's the only mathematical operation I can do to the top and bottom of a fraction? Multiply, right? Why do I mention that right before we do this next problem? What do you think a common mistake on it is? To try to add 4 to the left-hand fraction, and you can't add to get common denominators. Kind of the reason yesterday we couldn't cancel things that were added, it doesn't make sense. Same thing, we can't just add something in. So what does the left-hand fraction need? More than just a 4. Because 4 would just make it 4r, wouldn't it? It needs an r plus 4. It needs the entire right-hand denominator. Those two denominators have no common factors. They look kind of like they do because they both have r's, but remember, those are different numbers. So I get 5r plus 20 plus 8r all over r times r plus 4, which is the common denominator. Okay, let's look at the bottom left. Say that again. Oh, it wouldn't. Sorry. Again, glad y'all are on top of things today. Alright, the bottom left. What should I do before I start? Factor. Why would I want to factor? I want to see what factors they're made up of, because I really hope I don't have to multiply by that whole quadratic, because if I do, that's a very yucky problem. Notice once we factor, they already have the m plus 4 in common. So So what does the left-hand fraction need? M plus 2. What does the right-hand fraction need? Do I need to slow down? Are you okay? Both the top and the bottom. Because we don't want to change the fraction. So if I had 1/2 and for some reason I want the denominator to be 6, if I multiply by 3 on top and bottom, 3, 6, and 1/2 are equivalent. What do I have to do to multiply two things that look like this, two binomials together? FOIL. Good. M squared plus 2m minus m minus 2 plus 5m squared plus 40m minus 4m minus 32. Over the common denominator, which was m plus 2, m plus 8, and m plus 4. Combine like terms together. What do I get? Wake up. What do I get when I combine like terms together? 6m squared, because of the m squared and the 5m squared. And then the m's, the 2m minus m, which is 1m, plus 40m, which is 41m, minus 4m, 37m. And then the constants, the negative 2 and the negative 32 make and you could check quad 3 and see if that factored if you wanted to. I don't believe that it does. But I could be wrong. Any questions about that one? What time do we get out of here today? 30? I thought it was earlier than that. No? Alright, let's look at the next one. What do we do on it? Let's try it. Say we multiplied something by negative 1. Say we multiplied the right one by negative 1. Wouldn't that give me a negative x and a positive 10? Now, when can we play that negative 1 trick? When they're subtracting, but they're switched around. This one is one's addition, one's subtraction, so they actually have nothing in common and can't make them have anything in common. So what does the left-hand fraction need? An x minus 10. And what does the right-hand fraction need? Star this example in your notes because there is a really big place where people mess up a lot. Does anyone know what mistake I have made? Okay, this negative, do you agree it goes with everything on the top? So before I put it with everything on top, there's a parenthesis there, just an understood parenthesis. Does that make sense? So just be careful, star that in your notes, but be careful. Anytime you have subtraction, that negative goes with everything on top of the second fraction. So the 10x's cancel. And did I do that right? Oh, oops. I didn't make a mistake. I said I made it. This was a plus, wasn't it? Okay. So I get negative 100 minus 100 over x plus 10 times x minus 10, which is negative 200 over x plus 10 x minus 10. So you distribute the negative to both pieces. Okay. Any questions about that? Okay. I'm going to go ahead and pass out homework, but I'm going to do a few more examples. Oh, yes. Yes, I can. Victoria, will you pass that homework around? If you feel like you know what you're doing, especially since this is the second time I've taught this, you're welcome to just start the homework at this point. But if you would like to see a few more examples, I'm going to do a few more. But if you're working on homework, you have to be quiet and work by yourself. You can't work together yet because I'm still going to be teaching. So if you decide to do homework, you're on your own for right now. Some people would probably like to see a few more examples. Others of you are probably ready to go. Okay, let's look at this one. What do I need to do first? Factor. X. What are the factors of 6 that add to give you 5? Good. X minus 2, x minus 3. And then what are the factors of 8 that add to give you 6? Good. X minus 2, x minus 4. So what does the left-hand fraction need? What's the right one have that the left one doesn't have? The x minus 4. Good. What does the left-hand fraction need that the right-hand fraction doesn't have? This is subtraction, right? So what do I have to be careful about when I do this problem? Make sure that that negative goes with everything on top. What you could do is you could just move it up with the 28 to begin with so that you don't mess that up. You have options, but it needs to go with every piece on top. So I get 7x squared minus 28 minus 28x plus 28 times 3, which is 4, 884. Is that right? Y'all check that. Since I've already made 2 mistakes today, you should check. Is it 84? Awesome. And 56x. The 28 and, oh, I don't know. It's a great question. Let's try that again. The other 28 does not have an x, does it? Y'all are just going to let me do that. Thanks, Hunter. Negative 28 and 84 is what we should be combining, isn't it? I'm having an off day, huh? Sorry. This. Huh. Interesting. All right. Sorry about that. 3 in one day. Man. Okay, any questions about that one? I'm going to blame it on daylight savings time starting to catch up with me. I was fine at the beginning of the week, but this is the end of the week is starting to... Good thing spring break's next week, right? Okay, any questions about that? Okay, let's do another one. What do I do if there's 3 fractions? They all need to be the same. So this one needs an x minus 1. This one needs an x plus 1. What does the last one need? Nothing. Why not? Already has everything. It's the cool kid already, I guess. 3x. That was a 3x sitting there, wasn't it? So 3x times x is 3x squared minus 3x plus 4x plus 4 minus 6. Remember that negative goes with everything on top, but there's just a 6 on top. So combine like terms, and I hope y'all are checking my work since I've obviously been struggling today. Okay, any questions about that one? Do we want to see another one, or are we good? We're good? Anyone want to see the last one? So this one, I'm going to factor x plus 4, x minus 4. Quiet. Quiet. X plus 4 and x plus 1. You did get your homework. What does this one need that this one has? The bottoms. Only looking at the bottoms. What does this bottom have that this bottom doesn't? X plus 1 in factored form. X plus 1. Does that make sense? And what does the right-hand fraction need that the other fraction has? But it does. minus 4. You see how we're getting that? And Jessica, you see that? No. The x plus 1. So this one had 1. Notice that negative. I'm going to put it with everything on the top. So we have a minus 4x plus 16. I would stop it because the bell rings in like a minute. I mean, you're welcome to leave it if you want to, but that way you don't have to walk all the way back here. Any questions about that? Did it make sense? Okay, you have your homework. It's only 8 problems. I've had a higher percentage of people not turning in homework since a couple weeks ago, so I don't know what to tell you. I know you're seniors, but it's college class. You got to make C, so do your homework. It's only 8 problems. There's no reason to not do 8 problems. You don't have homework over spring break, so do this one. You'll be good. We are going to grade it tomorrow. The only thing we're doing in class tomorrow besides Pi Day is grading, so turn your homework in tomorrow.